Okay. Can you also see the presentation online? Wait a minute, I know you can't, just kidding. Okay. Got it.
All right. All right, well, welcome everybody to the Coriolix demo. I'm Jasmine Horniak from Oregon State University, and also here's Chris Ramzos. Raise your hand, there you go. We are from part of the Regional Class Research Vessel Program. And today I'm going to be providing a whirlwind tour of Coriolix, which is our data presence system that provides real-time access to viewing data plots and data and sensor metadata on both ship and shore. So this is the personnel behind Coriolix. There's Chris, as I already mentioned, myself. There's also James Kaysen. He's our design specialist. He took over Katie Watkins Brandt role, parts of that role, after she departed our project. And we also have a current position open for a new person to join our team. So if you're interested, there is a job ad out there. I'm going to break the demo up into 3 different sections. The first section will be the public components to the website. One thing I want to make clear is that most of the Coriolix site is accessible and viewable from anybody in the public. You do not need to have an account to access the site. I'm then going to take us deeper into have an account and elevated privileges, things like modifying sensor metadata and adding new sensors, for example. And then finally, I'll talk about our plans for the next couple of years with Coriolix and let you know how you can provide feedback, because we really value your feedback. Before I jump into what's going to be hopefully a live demo, data ecosystem on the ship and on shore. So on the very left-hand side, we start with a sensor. Usually it's something that's cabled, maybe serial feed, to some type of data acquisition system. At that point, the data are put on the local network on the ship, and a second data acquisition system, in this case, OpenRVDAS, captures that data message and parses the data, saves the data. It has a lot of functionality at the OpenRVDAS stage. The data are actually saved to flat files for archive, which eventually end up in the R2R cruise distribution. It also parses the data message and ingests the data into Coriolix. So on the back end of Coriolix, there is actually a database, and that's how we feed the information to our real-time plots. This is how the ship side set up. Data and the sensor metadata are also trickled to shore. So we have 2 pathways to shore. There's an MQTT client that trickles the data messages themselves. And then there's a second route where metadata in Coriolix system, because Coriolix also captures things like information about the sensors, those are synced between ship and shore. So this is the shore side, looks a little bit similar to the ship side. It's receiving the data messages. There's another OpenRVDAS sitting on the shore. There's another Coriolix instance sitting on the shore. Anybody who wants to access the data and look at real-time plots of the data on the ship are actually accessing a website on the shore. They are not touching the ship at all. And the only other new thing that happens on the shore side is that there is a daily distribution of data that goes out to SAMO so that they can do some quality control. The website I'm going to use today for our demo is actually on the RV Endeavor. There's a QR code there. You might not want to access it right now during the talk, just in case there's internet issues, but you are welcome to explore it at any point. And I'll also have some other links for you later in the slide for some other places. So I'm going to take you to All right. All right, so this is the Coriolix homepage on the RV Endeavor, and this is the shoreside site that's open to the public. The first few slides pages I'll show you are all publicly accessible. The homepage provides an overview of some of the different types and tools and things that are available in Coriolix. In the very upper left corner, you can see the name of the vessel, RV Endeavor, and on the right-hand side, there's the most recent data received, and it also lets you know that you are on the shore side site. The ship side site looks identical. The first page I'm going to take you to is under the status tab, and it's the sensor status page. This page provides an overview of the current status of different parameters coming from different sensors on the ship. There's a lag of about 1 or 2 seconds typically between the ship and the shore. So what you're seeing is really what's currently happening on the vessel. There are different blocks for different types of sensors, different parameters. So there's an atmospheric block at the bottom, navigation in the middle, and flow through at the top. Squares that are black mean that the data are flowing, things are looking pretty good. If the square is orange, then there's an issue. So this is a nice, quick, easy way to see how your system's functioning and if data are flowing. If you hover over one of the problem boxes, it lets you know what the issue is. So in this case, it hasn't seen data from this particular parameter from this sensor for at least 15 minutes. Right now, at the very top of the page, there's a little alert that tells us that currently the Endeavor is at port. Next page I'll take you to is a sensors page. There's a sensor list page. This is a list of all of the sensors that the Endeavor technicians have uploaded into the Coriolix system. This includes metadata about the sensors. Not all of these sensors have to be flowing data into Coriolix. Some of them are just sensors that they use for other reasons, but they wanted to include them as part of their sensor inventory. The different colors, the white and the gray, let you know which ones are the ones that are considered enabled. So the white rows are enabled sensors, which means that they are installed on the vessel and they're ready to transmit data as long as they're turned on. So they're the ones that you would likely see plots of real-time data from. There are multiple columns. This is kind of a summary table of the sensors. So as I scroll across to the side, you'll see more columns. It tells you things like this column tells us where the sensor is located. It tells us which UDP ports it's transmitting on. It also has a last calibration column. If the sensor is overdue for calibration, the date will turn orange. So this is a nice, easy list where you can check to see which sensors are overdue for calibration. You can also sign up for and receive alerts, text messages, email alerts, warning you in advance that a calibration is due for a sensor. You can sort the columns. So I'm going to sort it by the enabled value here. So now all of the enabled sensors are at the top of my list. On the left-hand side, you see some links, details, plots, and data. And remember that right now I'm just logged in as I'm not logged in. I'm a public user and I have access to these links. So I can go to this details page and it's going to tell me information about the sensor. There'll be a photograph of the sensor, tells me the serial number, where it is, what frequency the data messages are. It gives me a sample data message, a regex expression on how I parse that data message out in OpenRVDAS. There's a lot of different types of metadata that is available on this page, and not all of it is mandatory to include in the system. It's really up to the vessel themselves how far they want to go with how much metadata they would like to include. So I don't want you to freak out, but okay. Going back to that sensor list page, another link that was available was this plots link. So I'm going to click on that. This shows real-time plots of the most recent data collected by the instrument. There are, in this case, we have air temperature and relative humidity on the same plot. If you click on one of these tabs at the bottom, you can turn the plot off or on, so you can just view the one that you're interested in. You can also change the frequency of how often this plot is updated. So right now, by default, I have it updating every 10 minutes. But if you actually want to see it updating in real time, you can change it to 1 second. And depending on how well the internet's working here, you might see plots updating. Let's add this one back in. Let's see, and then back to the sensor list page. The other link that we had available was a data link. Slow. The data page provides you with access to data in a couple of different ways. At the very top, this real-time data section shows the current data values in real time, and they're updated as the data flow in. There's also kind of a snapshot, a little spreadsheet of the last 10 values that were collected. So if there's an issue, you might want to come here and check the spreadsheet and see if it's just an anomalous value or if it's a trend that seems to be happening. You'll also notice at this point that there's a flags column. We do some preliminary quality. There is documentation on the Coriolix site that describes what these flags mean. The values, like the number 2, the number 1, the number 1 means that it passed a test, and number 2 means that test hasn't been assessed. But all that information is available on the Coriolix site. At the bottom of the page, there's some quick, easy ways to download data. Now, this is a sensor-specific page. So if a user is only interested in data from this single sensor, these are easy buttons to download the data from just that one sensor. And there are many different ways to access data from the Coriolix site. You can access it at any point in time during the cruise. It's not just at the end of the cruise. This particular method is using an ERDAP server on the back end. We also have a REST API where you can access the data. So you don't have to manually come in and click a button to download data. You can also programmatically access the data using URLs. Okay. I'm back to the sensors tab, but this time I'm showing a list of parameters. These are all of the parameters that are available from the various sensors. So it's a long list. Again, this is a summary table. So you can scroll across to the side and see different things. This is where you can see, for example, the global range values that were set for an individual parameter and the units. Again, there are links to details in a plots page. Those take you back to those same pages that we saw earlier. There's back under the sensors list, there's a vendor manufacturer list page. This is all of the vendors that are currently uploaded in the Endeavor system. You can also, once you're logged in and you have the right privileges, you can add and edit this list of vendors. I'm going to take you now over to a sensors plots page. We have multiple, rather than just showing the individual sensor plots, we have them grouped by kind of category. So there's a flow through plots page with plots from flow through sensors. Let me take you to the MET page. So on the meteorological station page, there's some gauges at the top, and then the plots are organized hopefully in a meaningful way. So for example, on this top plot, we have all the air temperature from the various different sensors all plotted on the same plot. You as users have the ability to decide which parameters you want plotted on which plot and which order, which plot you want at the top of the page, the bottom of the page. That's all up to you, and it's very vessel specific. There is, in addition, there's a combination plot page. And this is again vessel specific. So you can choose if there's a set of plots that you always like to see together as a time series, and they're some kind of mix of flow through, meteorological, navigation, you can put them together on this single page. This is for your vessel and everybody can see it. It's kind of a one-stop page for you. Different from that is a customizable plots page, which is just user specific. So only I can see this plot. It's just me playing with data. If I want to look at a history, something's going on. And for this particular plot, you can choose your start and end dates. You can choose any sensor and any parameter that you want to plot together on this single plot. So it's more for checking in on things, playing with the data. I'm going to move over to the data tab since we were talking about data earlier. This is a list of different types of documentation that we have regarding the data. So the first one in the list describes the data structure, kind of the formats that we have available, the different data. There's a quality flags document that describes those flags I was mentioning earlier. Then there's a couple more ways to download the data. In this case, you can if I click on this one, for example. In this case, you can choose from any and all of the parameters that are available on the ship to download, to grab them all and download them together as a single file rather than going to individual sensors. I hadn't mentioned binned data yet, but one of the things that Coriolix does for for almost every parameter is bin the data into nice 1 minute intervals. So you have a nice binned data set for folks that just are interested in, 1 minute bins rather than all different frequencies at all different times. We also can do a second set of binning at any resolution that you choose or that the chief scientist decides they want for that cruise. The default is 10 minutes, but like I said, it could be hourly, half an hour, whatever it is that that user wants. Sure. Okay, so the question was, is it apparent whether a parameter is raw or derived? Not on this particular list, but there, let's see, if I take you to parameters page, I don't know if I have it on this part. No, okay. And I go to, let's see, what's one that's derived, for example. Okay, there's a processing status field. So with the parameters, there's a lot of metadata associated with each individual parameter as well. This is showing me that this particular variable, true wind direction, for this particular instrument, it was internally derived. There's different categories. So one is raw, like something that's in volts, or it just comes out that way. Internally derived. There's also parameters that are maybe derived. Wind product is from an instrument that's providing a true wind product, but we also derive true winds from multiple sensors and create a derived product. Does that answer your question? There is a way to find it. It just wasn't in that table. Okay. The final part on this data section here is a direct access section that again leads you to more documentation that describes how you would use the REST API or ERDAP, going straight to ERDAP, and how you might incorporate that into different tools like Python and so on. I'm going to take you to the last couple of pages that are again public. First section is cruise tools. There's a cruise list page. This is a list of all of the well, couple of years of recent cruises and all the upcoming cruises. All of this information on this page is derived from the Marine Facilities Planner. So they are the source of truth. I pull it into Coriolix, so it's locally available information on the ship, but it does go back and keep checking Marine Facilities Planner in case there's updates. And finally, there's a cruise chart page. This might be a little slow to load in here. This provides a map and shows the current location of the vessel. It would, if the Endeavor was at sea, it would show a track line. You can even display color-coded track lines depending on parameter like chlorophyll or salinity. There's other different features on here. Let's see. Yeah.
It's offshore and which tool is being used.
Do you want to do it? It's we used to do map server. We recently correct, and that's machine notable.
Yeah. So you can also things like plot stations on the map. And there's a lot of functionality in this chart that I won't go through, but it's kind of fun to explore. So for the next section here, I'm actually going to log in. Let me move this back over. Yeah. You wanted it, the question was whether you can download the track, but you wanted it specifically, if I recall, as a KML or something, or all of the data, including navigation data, are accessible through all of the same ways that you can access any of the data. So you could use the REST API URL to give it a date range. You could give it limits and download it that way. There's several different ways you can access the track data. Okay, so I'm going to log in. Okay, now I'm logged in and I have elevated privileges. Under the my account now, my name, there's a delay. My name shows up. There is a tab called My Alerts. And I mentioned alerts a little bit earlier on. Alerts are things that you can choose to subscribe to or not. There are several different types of alerts. You can create your own custom alert. So if a scientist is interested in knowing when chlorophyll is above a certain value, they can receive an alert, and they can create their own alert. There are what I call proximity alerts. So if you the different vessels that Coriolix is in port, and so that's what I subscribe to. And I receive a text message and an email letting me know when it has arrived in port, and I get another one when it leaves port. There's also sensor alerts. So if you want to know that a sensor has gone offline, you can subscribe to those.
Whether the ship is underway or tied up as a condition for alerts. For example, my flow-through system is not working. Well, if you're tied up, you don't buy it. It's supposed to if you're underway.
I
Right,
do
I
not
do
use that as
that as a condition.
to see an alert. Um. Yeah, yeah, yeah. I guess I kind of figured that people would want to know if it was turned off regardless of the situation, but we could make that be part of it too. Yes, true. Okay. The other thing I want to point out is that Coriolix does not have embedded internally with it a concept of a cruise. You don't have to start a cruise. There's nothing in Coriolix to start when you start a cruise. Everything is running, the data are flowing. You turn your sensor back on, the data just starts appearing on the plots. The only time there's a cruise concept that comes in is at the end of the cruise when we're packaging up the data for R2R. Then we look at the cruise dates from MFP, from the Marine Facilities Planner, and say, oh, look, we just finished a cruise. Here's the dates. This is the range of data that we're going to provide. Other than that, there's nothing that a tech needs to do in Coriolix to say, hey, the cruise has started or ended, so you don't have to worry about that. Okay, now that I'm logged in, I'm going to go back to that sensor details list page. And what you're going to notice is that on the left, when it comes up, there are a lot more links available to me now because I'm logged in with elevated privileges. So we had that same details, plots, and data links. There's now an edit link, which takes me to a form that allows me to modify the sensor metadata and make changes. There's a duplicate link. So if you have another sensor that's the same, a spare that comes on board, you can duplicate the metadata from an existing sensor. Let me just take you quick there. All you do is give it a different ID, a unique ID, and a different serial number, but all of the rest of the metadata are copied over for you. And then you can take it from there. There's a log tab. One of the things that I hadn't mentioned yet is every time somebody makes changes to sensor metadata within Coriolix, every single change is captured automatically in a log, and who made the change and when. So this history down below my sensor log field is a history of automated things that were captured in the log. But in addition to that, you can add your own information to a log in a free text field. I deliberately kept it simple. So there's a date time section. You can modify that if it happened yesterday. There's a drop-down list of activity types to choose from to help kind of categorize the type of event. And then you can just free text in whatever details you want. And that becomes part of the log. You can also download the entire sensor log with a button. And on the right-hand side here are all of the sensors. So you can access the logs from all of the sensors from this page. Okay, going back to my sensor list page, other options available are change ID. If you absolutely have to change the sensor ID, you can do that, or deleting a sensor. Deleting a sensor is only available to the most highest level privilege accounts, not a general support accounts, just so you don't accidentally delete the sensor. It does ask you for confirmation, but then another page to take you to is the documents page. This is a list of all of the documents that have been uploaded to the system. Stored locally on the ship. So if you need to access a user manual, you're not calibration files. I have scripts in place that will parse the calibration file out, pull out the calibration numbers, store them in a table. So when we process the data, anything that needs calibration corrections done, those values are available to be used on the fly. And final sections I'm going to take you to, there's a data management page. You have the ability to edit these values here, but I'm going to point out the bottom section here where you can determine as the operating institute how much data you want to store on the vessel and on shore, for how many days. That just depends on your storage capability and your needs. Then, as a high-level privileged user, I have access to account management, so I can assign account levels from this page. And then finally, there is a system management page. This has a magic green button. If you make changes to Coriolix metadata, if you added a new sensor, if you changed where the sensor was located, or maybe you changed the configuration of a sensor so the data message has changed, you need a way to tell the rest of the system, like OpenRVDAS, that these changes have happened. So this button goes off and propagates to the rest of the ecosystem and lets all the other components know. They get updated, restarted, and your system is now updated to include your newest sensor. OpenRVDAS talks to Coriolix to find out how it needs to be configured. You do not need to go in and manually modify configuration files in OpenRVDAS. They are automatically generated for you based on the information it finds in Coriolix. So how you update OpenRVDAS by pushing this button. And at the very end here, there is an About tab that describes things like how you can provide feedback to us. There is also a list that we provide of all of the vocabularies that we use. We try to use as many standard vocabularies as we can. So this is just a list of all of the ones that we're using. Okay. Now I'm going to switch back to the slides, and I just have a few slides to finish with. Okay, so this next slide, when it pops up, is the slide I showed earlier of the ecosystem on the ship. And I'm just going to focus in on the OpenRVDAS component that I just mentioned, because I wanted to highlight the functions that OpenRVDAS does for us before the data get to Coriolix. The first thing it does is read in the UDP data messages from a sensor, saves a backup of the raw data locally to that same server. It prepends a timestamp right at that point. So we try to prepend the timestamp as early in the process as possible. We also prepend a sensor ID so we know exactly which sensor the data message came from. And that data, that prepended data, now gets saved in a file, a flat file, daily files, which are later then sent to R2R. After that section is done, we then parse the data message using a regex statement. Regex looks horrible and complicated. You get used to it after a while, but it's how the system knows which numbers to pull out and what they mean, and so that we can ingest the data into Coriolix. If the data need to be calibrated or processed in some way, that also happens at the OpenRVDAS stage. We also can correct the timestamp if necessary. Some sensors, there is a lag between when the data are collected and what the timestamp should actually be. So at this point, we still keep the original timestamp, but we have an extra corrected timestamp that we provide. It also calculates the preliminary quality flags for you and inserts the data into the Coriolix database, and then rebroadcasts the processed data via UDP. So if other folks on the vessel actually want these process data, they have access to it on the network. For the demo, I was using the Coriolix installation on the Endeavor for this demo. We also have installations on the Point Sur and Coriolix, which are these shoreside sites are also publicly accessible. Going into the future, for the rest of this year and going into 2024, we will be working with this list of vessels. We are, of course, continuing work on our RCRV vessels, so the Tawny, the Mason, and the Dawn. When those vessels are given to the Operating Institute, the Coriolix will already be pre-populated with all of the sensors. They'll be streaming data. They'll be ready to go. Also coming up is we are putting a new installation of Coriolix on the Savannah through a special service grant. We will also be putting a new installation on a NOAA test bed using funding through NOAA and Simmers. We will be increasing support with Coriolix. So they currently have it installed, and we're going to help them get some more data feeds flowing. And again, that's through the special service. And we'll continue to support the Endeavor and Point Sur, who are our operating institutes for the new RCRVs. We really appreciate all of your suggestions. If you want to contact us, there's an email link there, or you can contact Chris or I directly. There's also a little green feedback button on every Coriolix page. So if there's an issue on a page, using that button provides us with a snapshot of the issue. And Coriolix was put together with the help of a slew of folks, and so I just wanted to acknowledge everybody's input. Yes.
You're saving the raw data, the original raw data, so it's
so we are saving the okay, let me go. Oh yeah, I guess that's not. Ooh. Yes, we so I'm pretty sure the only files we are saving for you right now are the annotated files. So the annotated meaning it has the timestamp and the sensor ID in front of it. And then the rest of the data message is unchanged.
There's a issue with that. Use it long-term NCI.
Okay. We can certainly do that. Okay. Yes. Oh.
What's the database?
The question was what the database mapping is and who
The second question is it possible to integrate an external user identification, like Active Directory or some other LDAP mechanism?
We are exploring that because we may have to. Yeah. Yeah. So the question was whether you can use an external authentication method like LDAP instead of using like Coriolix specific usernames and passwords. And we are working towards that. We're just kind of waiting on input.
Yeah, so when we we started with the local have given the community. Yeah, I would definitely recommend that. Next step. Oh,
Yes, Jules.
What if somebody had some sort of instrumentation on their?
I'm specifically going to use multi-beam as an example. And some enterprise person decided they wanted to keep the same to Coriolix. Two questions. What do you do with EEZs? Two, they repeat it to you.
Those are two very different questions. So the two questions, two questions were basically bring your own sensor on board. How could that data be fed into Coriolix? And the second question was about EEZs and how we manage that. Okay, so the first one for a new sensor, a BYO sensor brought on board, you could treat that just like any other adding a new sensor to the sensor list. So you need to provide some preliminary sensor metadata. In Coriolix, there's even spaces to say who owns the sensor, so you know that it's not owned by the vessel. Part of that metadata would include what UDP port that data is getting transmitted over. It gets treated just like any other sensor, basically. It's just added to the list. Once that new sensor is added, you would have to push that big green button to propagate that information to OpenRVDAS so that it knows about the new sensor. It knows to listen to the port. It needs to know how to parse the message. So it needs to know, it needs a sample data message. It needs a regex expression to say, hey, this is how I parse the message. Yeah, and then the data will flow in. As far as EEZs go, we have been, the method that we're going to adopt at this point in time is that it will happen on the OpenRVDAS end. In OpenRVDAS, you can have different sensors have different functions happening, like a different mode. What we are waiting to hear from the community is where, if there's a document that exists that tells us exactly what is allowed to be captured and what is not allowed to be captured in an EEZ, because we want to follow the strict guidance. Once that's done, it'll be as simple as the user will select, I'm in an EEZ, and the OpenRVDAS will change. Right now, manually, you can just go to the OpenRVDAS list of sensors and just say off, 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 off on the ones that you need to turn off, and then you turn them back on again. But I want to make it even easier than that, so you can just select EEZ and it would just turn off the ones that shouldn't be on. Right. If anybody happens to know if a document exists that tells me no. Sean?
Yeah, I was gonna say, have to figure out who
we have to talk to, but the World Meteorological Organization, I'm sure, has gone through that whole legalese for atmospheric data over the ocean. And that also includes sea temperature. My understanding goes far, and don't quote me on this, I'm not legal. But my understanding is those are allowed anywhere in the world. Weather and sea surface temperature can be collected for safety if I could see.
Yeah, and I thought the same, and I looked it up, and there was another section that said that the marine science data, I forget what the term was, it said it's very loosely defined, but then it went on to define it to include metadata. So that's why I'm seeking the official guidance.
I think we can find the right people to talk to.
Okay.
It's really going to be, it actually is finding who you need to talk to.
It's as easy as that.
Yeah.
Pablo, I think you had your.
I was going to make a comment following up on that.
Also following up on that.
So I haven't implemented it, but I've had a few requests to implement a writer module that can actually act on the OpenRVDAS control database, such that when you get, for example, these variables match these conditions, it will change the state so you could actually have
we'd ask geofence, when a detected at this combination of black and long, for this range, you send command to, let's say, change the mode, turn these things on, turn these things off. I've had that request past, nobody's kind of pushed me for it. But, yeah, so I'm scared of trusting, diplomatic instruments.
Yeah.
Part of the problem there is that, I think there are
Legal subscriptions that you can get to these which are changing and which are disputed.
Yeah.
And the open source one, yeah, is good. The ship doesn't, and says you're yes, or how trustworthy it is. Right. But it really, it still comes down to making the button she was talking about. It's a simple one on how it's
If there's no map, you can't do it. There has to be a precise map. Yeah. That does exist, and there's nothing else. Yeah.
I was just gonna say, I mean, it's like regardless of the situation, it's not that she's fine.
Yeah.
Right. So I am keeping that in mind, and I do want to make it so that you can adjust which sensors are allowed on in the EEZ. Yes.
Have local representatives so that data to easy for us and then they have something up to now we'll chop it in.
Meaning you want the raw data files to be separate. Oh, interesting. Yeah, right now, all of our data files are daily. So that does make it a little bit easier in that they're smaller files. It's not like a cruise length file. They're daily files.
Daily files for a while, and so it's always an issue of what can we keep, so we all can get the daily file. See, it should be representative, because not all of the cut.
You can always do a geographic query database. Post hoc, right? The raw files that John was talking about are organized by day, but if you free yourself from the raw requirement, not that it's not important, but in this use case, you can, there's a lot more information that you can build a query to get it.
I know in the past, we gave them the raw but talk to the representatives. We could probably summarize this for the people online by saying a complicated discussion ensued.
We got one more question.
You go over a little bit, the kind of metadata information that percentage are samples.
Okay, so yeah, so they're very different, the two, SAMLOS and R2R, how the kinds of metadata and how they're receiving it. SAMLOS has a very specific metadata format. It's an XML format. And they have requested specific types of metadata that they're interested in, and that's what they're getting. Things like the serial number, the orientation of the sensor relative, like for the wind anemometer sensor, and that they get updated information as that information changes. If the metadata changes, they get new metadata. They get that daily. R2R, we're still working with them on what exactly they want. We could give them everything. but the format is yet to be determined. We are currently planning to, in these daily R2R, we've just mentioned that our data files are daily. Our current plan is at the top of each daily file, there will be some metadata about the contents of the file, you know, what the columns are, what the sensor ID was, a serial number. The most important metadata will be in the file so that the metadata follows with the data. We are still working on what format that should be in, but we want to keep it pretty simple for archival purposes so that it's not something that's going to be obsolete in 10 years.
5 minutes to get coffee and come back for Samos. Thank you, Gabby.